So here's a claim you could make if you're at a party with your friends and they like math. You never know, it could happen. You could say, hey, I'll bet you $10 that 0.9 repeated is equal to 1. And your friends say, oh, I'll take on that bet, because they don't know anything about math. They haven't taken this class. So how do you prove it? Well, okay, we're going to prove it using an infinite geometric series. There's other ways to do it. So 0.9 repeated, remember what that means? 0.9 repeated means 0.999. Now you could do this, you could keep writing nines the rest of your life, right? But that wouldn't be very fun to spend, that wouldn't be a good way to spend the rest of your life, so just go ... 0.9999 repeated is what 0.9 with the bar over it means. So now I want to write this decimal as an infinite geometric series. And I can do that as follows. I can write it as 0.9 plus, okay, I'm going to put a 0 after the decimal, 0.09, and then for the second term, and then for the next term, I'm going to write down 0.00, 2 zeros and a 9. It's going to increase by 1 0 each time. For the next term, how many zeros after the decimal? 3 of them, 1, 2, 3, and then a 9. And then I think you see the pattern. Now, why is this the same thing as 0.9 repeated? Because when you add them back together, the nines fill up the 0 slots, don't they? Yeah. But this is an infinite geometric series. So we can use a sum formula to find the sum of that thing, and we're hoping the sum is going to be 1, right? Because that's the claim anyway. So in order to find the sum, we need to use the formula A1 divided by 1 minus R. What would A1 equal? So just look at the list. Just look at the sum I made, 0.9. And then what else do we need? To use this now remember, the formula tells you what you need. You don't need to memorize steps. Memorize the formula. The formula tells you need A1 and R. So we need R. Okay, so what's R going to be?
110?
Yeah, a couple different ways to look at it. What could I multiply 0.9 by to get 0.09? And if I find that number, can I multiply it by 0.09 to get 0.009? And then can I multiply 0.009 times R to get 0.0009? What would that have to be?
In digital purposes of 0.1?
Yeah. So if you multiply by 0.1, remember, that moves the decimal 1 point to the left. So each time, if you multiply by 0.1, 0.1, you're going to generate a new term in the sequence. The next term in the sequence if you multiply the current term by 0.1. Another way to get it would just be what I showed you in the last example. Couldn't you take 0.09 and divide by 0.9? And a little bit of thought will show you that that's equal to 0.1. So we've got everything we need. Fill it in for me. What's S going to equal? What goes on top? 0.9. On the bottom, 1 minus R is 1 minus 0.1. And what is 1 minus 0.1? You get 0.9 over 0.9, which is 1. So you win the bet. 0.9 repeated is really equal to 1. So what we just did is the first example really of a problem with these directions. Write as a rational number. Okay, a rational number is a number that you can express as a fraction where the numerator and denominator are integers. And for many people, that's going to be like, well, that doesn't help. That definition doesn't help. So an integer is a number like 1, 2, 3, 4. It's a counting number, but it's also a number. It can include 0, and it can include the opposite of the counting numbers. -1, -2, -3. So, and then ... These are integers. So a rational number can be expressed as a ratio of 2 of those numbers. So like pi is not a rational number. You can't express it. You can't take 2 of these kinds of numbers and get pi. its decimal representation, another feature of an irrational number, or a feature of a rational number, I should say, is that its decimal representation will either terminate or repeat. Whereas an irrational number like pi, its decimal representation, first of all, you can't write it as a fraction with one of these in the numerator and denominator. And decimal-wise, its representation will never terminate and never repeat any recognizable pattern. So a rational number doesn't do that. So like 0.63 repeated is 0.63, 63, 63, 63. So its decimal representation, it doesn't terminate, but it does repeat. And so it should have a fraction representation. So when you see the directions write as a rational number, it's really saying write as a fraction with an integer in the numerator and an integer in the denominator. Okay, so let me show you the trick. There's just one slight variation. So let's rewrite 0.63 repeated as an infinite series. And by the way, I expect if I test you on this, I expect to see all these steps. Because you can use your calculator to find the answer here. If you put in 0.63, 63, 63, 63, 63, 63, you can hit the fraction button and it'll come up with the right answer for you. But guess what your calculator is doing? It's using the formula that I'm about to present to you to do it. So this is where it comes from. So 0.63, or something like it anyway. I actually don't know what your calculator uses because the information is proprietary. The code is proprietary. But it'll be something along those lines. 63, 63, 0.63 repeated. The two digits, just 6 and 3, just repeat over and over again. Now the trick then is to write this as an infinite geometric series so we can identify A1 and R and use the sum formula. So here we have 2 digits repeated. So you have to start by writing out 2 digits. So 0.63 in your first term. And then you have to fill up to get the infinite series such that when you add it back together, you get 0.63 repeated back. You have to put 2 zeros in because you have 2 digits being repeated. So you have to put 2 zeros in and then a 63. So that when you add these two numbers back together, 0.63 plus 0.0063, you get 0.6363 back again. And then if you add 2 more zeros each time and then a 63, you'll have your infinite series. So what should the next term look like? 2 more zeros and then a 63. Now does everybody see how it works? Then when you add them back, these two numbers, 6 and 3, will fill up these 2 slots. And then these 4 numbers, 0.6363, will fill up these 4 slots. And then you could continue the pattern indefinitely, just ... And that's your infinite series. Okay. So can you tell me, okay, let's see. Let's write down the formula. S is equal to A1 over 1 minus R. So keep that in mind. Can you tell me what A1 is? 0.63. Can you tell me what R is? It is 0.01. Does everybody see it's 0.0? Not 0.1 anymore. 0.01 because the decimal has to move 2 places to go from 0.63 to 0.0063. The decimal has to move 2 places. To get it to move 2 places, we multiply by 0.01 or 1/100th. And same thing over here. It has to move 2 more places, so multiply by 0.01. So R is 0.01. And if you wanted to, you could just, on your calculator, take 0.0063, divide by 0.63, and you'll get 0.01. Okay, so now plug in the formula. You get S is equal to A1. What's that?
0.63.
And then 1 minus R? 1 minus 0.01. So you get 0.63 on top. What's 1 minus 0.01? Careful.
0.99.
A 0.99, yep. So think of it as 1.00 and then subtract 0.01, right? Now, can I get rid of the decimals pretty easily? If you multiply the numerator and denominator by what number, you get rid of the decimals? 100. So 0.63 over 0.99 is the same as 63 over 99. Now reduce it. What number goes into both 63 and 99? 9. Well, 3, yeah, but you're not wrong. You're not wrong. But okay, so then 9 goes into 63 how many times?
7.
And 9 goes into 99? 7 11ths. Could you check that? Put 7 divided by 11 in there on your calculator, and you'll get 0.63 repeated. Until the very end, in which case, in certain cases, it might round. So we need a break. However, I will say this. What if it weren't 0.63 repeated? What if it were 5.63? You'd cut off the 5 and start out exactly the same way, and then add 5 back in at the end. So at the very end, you would say 5 plus 7 11ths, which is 5 and 7 11ths. Now that's not in the fraction form, so you'd have to multiply. You'd have to put it in improper fraction form. 5 times 11 is 55, right? Plus 7 was what, 62? So you'd have to write it like that, okay? But that could come up on the homework. Just be aware of that.